Hi, this is the second image processing tutorial. In this tutorial I will tell you that how you can add or subtract two images together. So I'm going to create a folder. I'm going to save a file, and now I will load two images. I'm going to load two images. I'm going to right clear all and close all to clear the command window, figure window, and the screen. After that I'm going to create a section. In this section I will load the images. Matlab. I am going to add two images. The first image name is IM1, and I am going to load the image of rice. This is a PNG image. I am going to run this file so that I may know that whether the name of the file which I have written is correct or not. Since this image is already present in the MATLAB library, so I don't need to download it from somewhere else. So I have loaded the image, and I would like to show you that how this image look like. You can see this is the actual image. The dimension of this image is 256 x 256. Now I am going to load another image, and I am going to store it with another name. The name of this image will be cameraman. So this is the second image. I have loaded both of these two images. Now I am going to display the second image so that you may know that how this image look like. Now you can see that there are two images, IM1 and IM2, and you also know that the image pixel intensity ranges from 0 to 255. The 255 represent a white color, and the 0 represent a perfectly black color. If I add these two images directly, like I write I3 is equal to IM1 plus IM2, then there will be a problem. Since the dimension of both of these images are equal, IM1 and IM2 both have the same dimension, so mathematically it is correct to add these two images, these two matrices. Then mathematically there is no any problem. When I run it, you can see that there is another image, I3. The dimension of I3 is similar to the first and second image dimension, and if I open it, you can see there is a 255 pixel intensity at this position, and this is the first image pixel intensity, and this is the second image pixel intensity. Now look at this, 122 plus 156, and the result is 255. So the addition process has truncated some values because the integer cannot store a value larger than 255. So the first value at this position was 122, and the second image value at this specific position is 156. So 122 plus 156 is equal to 278. However, some intensity has been discarded. This is the reason. Similarly, if you want to see the result of the first row and second column, this one is 251, this one is 92, and here it is 159. Similarly, here at this place, this is the 70th row and 13th column. 70th row and 13th column, this one. Here it is 103 and here it is 162. So 103 plus 162 is 265. However, if you see here, the result is 255 instead of 265. The result is 255. So it will add two values in a correct way. However, if the value exceed 255, then it cannot store, since integer cannot store a value larger than 255. So any value which is equal or larger than 255, if the sum of two values is equal or larger than 255, the resultant matrix will store 255 only. The remaining intensity values will be discarded. So now if I display this, you will see a problem. If I run it and I display it, you can see there are some places where the information has been completely gone from this position. Like, I'm going to display all these images in one figure, so that figure 1 I am show IM1, second image, and I will write subplot and now you can see this is the first image, and the rice images or the rice objects were also there at this position, but in the result you can see that there is no any rice image at this position. So some of the information have been lost. So it means that we cannot add two images together through this process. But there is also another method through which we will add the images, and I will tell you that what is the drawback of this procedure. If you write it like that, if you add two images in this way, that you add the pixel values of both of these images, and then you take an average of pixel intensity, and you identify, you create the mean value through this process, that you add the first image pixel value with the second image pixel value and then you divide it by 2. This method will also create a hurdle. There will also be some information lost within the image. Now I'm going to show you the result of this procedure. Now you can see there is also a problem, that here still the information does not exist, because when we add two images, like the first image is pixel intensity, the first pixel intensity which is at position 1 1, when it has been added to the first pixel intensity of the second image, when 122 and 156 is being added together and you divide the result by 2, the answer should be 139 at that position. At the first pixel intensity position, the answer should be 139, but here you can see that some of the information is still lost within the result and the answer is 128. So this procedure is also incorrect. Now you will be thinking that how 128 came here. So the answer of this question is that when you add two images together, when you add these two matrices together, actually these are the matrices, and you add these two matrices together, the result will also be an integer value. So when two integer value whose result is greater than 255, then some of the information will be truncated. So when when these two values are added together, the result comes out to be 278. So the result of this thing comes out to be 278, but since these are the integers, so the resultant matrix which store the answer of this addition procedure will also be an integer, and the integer cannot store a value larger than 255, which we have seen in the previous case. So 255 or 256 divided by 2 and the result is 128. So what will be the correct procedure to add two images, since if we directly add two images the result is incorrect. You can see some of the information in the previous image was lost at this position, and similarly when we add two images and then we divide it with the mean value which is 2, again there is some sort of loss of information. So what we will do is we will divide both of these images with 2 and then we will add the two matrices. Now when I calculate the result, you can see that there is no any loss of information and every pixel intensity value has been correctly added. And now if I show you the result, this is the pixel intensity value of the first image 122, is the pixel intensity of the second image which is 156, and the result of 122 plus 156 divided by 2 comes out to 139, and you can see the result is 139. Through this process you can add three images. If there are three images that you are going to add with each other, then you will have to, suppose I am going to add the third image. Suppose I am going to add third image, which is the image of a cone, and I'm going to store it in the third variable. And I have to add these three images together. Then I will write here 3. Third image, and the result will. Now if you see the result, okay, it says that there is an error, and the error is, okay, this is one of the important error, that the matrix dimension doesn't match. As I have already told you that when you are going to add two images, the dimensionality of the images should be similar. This should be equal. So since the dimensionality of the first and second image is 256, and while the third image has a different dimension, so I will transform the third image into the same dimension which has been mentioned over there in the. So M3 will be transformed to a dimension of 256 plus 256. Now if I run this code, you can see that all the three images, IM1, IM2 and IM3 have the same dimension. And if you look into the first image, second and the third image, okay, there is an error. I have to change this value. Now if you look into the first, second and third image, and you can see the result of these three images is here. It is another problem. The third image, which is this one, the third image is within some other format, so I think I should replace this image. I'm going to replace this image. This is also a built-in image already present in the MATLAB workspace, MATLAB library. Now you can see these are three images, the first, second and third image, and when I have added a color image, and you can see all the image exist within the result, and you can see that there is no any loss of information, but all the three images exist within the result. So the main things which you have to note while adding two images is that you have to load the images into variables, and then after that, when you add all the images into variable, then you must have to make sure that the dimension of the three images are two images, and whatever images you want to add, the dimension of these images should be uniform. The sizes of the matrices or the size of array which store the images should be equal. Third thing which you have to make sure is that you must not add the images directly, like IM1 plus IM2 plus IM3. This is the incorrect method. You will lose a lot of information. Neither you should add all the three images and then divide it by the mean value, which is 3 in this case. Similar in the second method, if you add all the three images and divide it by the mean value, again you will lose a lot of information. You will have to individually divide the value with the mean value, which is 3 here. If these were two images, then there will be a 2 over here, and after that you need to add the images, so that will be the correct way and there will be no loss of information. Now if I have to subtract two images to find the difference, I write another section, subtraction of images. Now at this place, this is the first image and this is the second image, and I'm going to, for instance, I'm going to comment the third image, and I'm going to add the first and second image together. You can see the result. This is the first and this one is the second image, and I have added the result. I will write it, addition, result. Now I am going to subtract the first image from the result, and I will show you that what is the difference between these two images. The difference between these two images will be placed at the other position, which is here. In order to subtract the result which is being stored in the I3, I am going to create another variable which is I4, and I am going to subtract the I1, IM1 from I3, and you will see there will be some loss of information. I am going to show you the result. I'm going to show you the result. There is some loss of information. And the reason is that when there was the addition process, in this addition process I have divided both of these two images with 2, and then I have added these two images, and the result, which include the average pixel of both of these images, contain the half pixel value of the first image and the half pixel value of the second image. So what I need to do is I need to divide the first image with 2, and then I need to make some more changes. Then you can see that now when I have subtracted the 50% value of the pixel value of the first image from the result, you can see that the subtraction result look like the original second image, but it is a bit dark. Reason is that I have also divided both of the images with 2, so I will need to multiply the result with 2, and now you can see that I have added 2 images and the result was this one. And when I have subtracted from the addition result the first image, the average of the first image, the resultant image was dark, but when I have multiplied it with 2, now you can see that both of the images are exactly similar. So this was the MATLAB second tutorial for the addition and subtraction of the images. I will create more tutorial on demand. Thank you so much.